this video, we will go over section 1.7, analyzing graphs and piecewise function, but I'm only going to go over example 1 and 2, the first page of section 1.7 notes. So we will come back and do piecewise function in our later videos, okay? All right, so the first learning objective is to read key features of a graph. So we are going to talk about increasing, decreasing, constant intervals, and evaluating functions graphically. So the first example that I have is to find where a function is increasing, decreasing, or constant given the graph. So as you can see in this picture right here, we have a couple sections that are increasing from left to right. So what I'm highlighting with red, these are increasing, okay? We're going up from left to right. Now, we are going down from left to right. So that section only is the decreasing section. And lastly, the constant section is just where we have these flat horizontal lines. So we have two intervals that are constant. When you are writing your answers in interval notation, make sure we are using the x-coordinates. So use the x-coordinates to write the right intervals. Okay, so do not look at any of these y values, so you're not really using any of these y coordinates. Just use the numbers on the x-axis. Okay, so first increasing interval from what's the x value that correspond to this point? And you can see that is -7. So it's increasing from -7 to, it stops going up at -6. -6. So that's the first increasing interval. Oh, let's do another increasing interval. Another increasing interval starts at this point, and that point, the x-coordinate of that point is -2, and it stops going up at 1. So we have two increasing intervals. One from -7 to -6, and the other one from -2 to 1. I just put the union symbol in between them, but I'm not sure. Maybe on your homework, you may have to just put the comma. But we're done with increasing. Let's look at decreasing interval. Hold on. This is bothering me. All right. So decreasing interval starts at right there, at this point right here, right? So it starts decreasing starting at 1, and it's going down, 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 and it stops right there. And this point has an x-coordinate of 3. So decreasing from 1 to 3. All right, let's read those two constant intervals. It's constant from -6 to -2. So I'm going to say -6, -2. And the second constant interval starts from 3 to 5. Make sure to use the x-coordinates, not the y-coordinates when you are writing these intervals, and always read from left to right, okay? All right, let's read some function values. Let's evaluate function graphically. You've seen this notation before, right? So f of x means, and f of x is it represents the output. It's the y value when you plug in a certain x value. So if they are asking you for f of 1, what they are saying is find the y value when x is what number? 1. That's what they're asking, okay? So at 1, do you see how we have a point right here at 1? Now we do need the y values, right? So I'm going to go ahead and erase or bring back those y values. So we have a point at 1, 3, right? That's the order pair for that point. So f of 1 is equal to, the y value is 3. So that's how you evaluate the function notation. So if I do another one, f of 5, they're asking you to find f of 5. What they are asking is find the y value when x is 5, okay? X value of 5, we have a point right here, and that order pair is going to be 5, -2. So when x is 5, y is negative 2. So f of 5 equals negative 2. Okay, let's keep going. I have two more points. Well, I have f of negative 4. So what is this asking? If I have f of 4, they're asking you to find the y value when x is equal to negative 4. So right here, when x is negative 4, we have a graph over it. They didn't really have a point there, but dots, infinitely many points, they make up a line. So if you just have a solid line, a graph, we do have a point right there. So we have a point at negative 4, negative 1. So f of negative 4 equals negative 1. Last one. Now this one's a little tricky. So if we read this one, they're asking for find the x value, right? Find the x value whose y coordinate is 3. That's what it is asking. Okay, we're missing the input. We know the output better be 3. So which x value has a y value of 3? So y value of 3, oh, hey, we saw it right there. We see it right there. When x was 1, y value was 3, right? So f of 1 equals 3. And I don't see any other point on this y equals 3 horizontal line. Any other point on that y equals 3. So that is the only answer that we have. Alrighty, let's try one more example right here. So this graph, let me go ahead and just use some of my colors to identify, is increasing from negative 3 to negative 2 and increasing from 1 to 5. So those are the increasing intervals. Let's write those down. Okay, increasing from negative 3 to negative 2. Where am I getting these numbers from? I'm really just reading their x coordinates. Okay, so make sure to use these x coordinates. So that's a very short increasing interval, but hey, we got it. All right, what's the next one? The next one starts from what number? The next one starts from 1. Okay, it's going to be 1, 2, and it stops going up at 5. So the second interval is 1 to 5. Let's look at the decreasing intervals. It's going down from that section, another going down over here, and another going down right there. There's no constant section. That's what I noticed. I'm going to go ahead and say constant is none. There's no flat horizontal line anywhere. But we have 3 decreasing intervals. I think you are just going to put commas in between your intervals on your homework. So I may just do that. All right, decreasing negative 5 to negative 3, comma. All right, this one's hard to see. Let me go ahead and drop down a horizontal line. Vertical line. And the second interval starts from negative 2. So I'll write down negative 2, comma, 1. And the last decreasing interval starts from what number? 5 to 7. Okay? All right, we're doing good. Now, I already said there is no constant interval. There's no horizontal flat line anywhere on this graph. Let's read some function values. So what is f of 5? So f of 5 is y value for x of 1. When x is 5, we have a point right here, and that order pair is 5, 3. Therefore, f of 5 is 3. Okay? What's the second one? They're asking us to do f of negative 2. Y value for x of negative 2. So let's find that point. Negative 2 is right here, and we have a graph, or we have a point right here, and that point is negative 2. What's the y value? 6. So f of negative 2 is 6. All right, almost done. We have f of negative 7. So this is the x value. X is negative 7. What is the y value? When x is negative 7, we don't have a graph anywhere. So guess what? We don't have a y value. So no y value. So I'm going to say undefined, because this graph is not defined at x equals negative 7. We don't have a y value. There's no y value. Okay, I should say, we don't have the name of this function. This function is not defined at x equals -7, because we don't have a graph here. You see, the domain, and well, that's a very good point to review. The domain is only from, we have a point. So bracket -5 to 7 bracket. See, -7 is smaller than -5. So obviously it's easier to see how we don't have a graph. Our graph doesn't go as far as -7 to the left. So that's why it's undefined at x equals -7. All right, last one. They want you to find an x value. Find an x value whose y value is 6. Okay, all right, let's find that. So you know what, I think we have multiple answers over here. Here is my, I'm just going to draw a horizontal line to catch any points that are touching y equals 6, and I see 2 points. Do you see 2 points? I have one right here and one right there. -2, 6, and what's that one? -5, 6. So not only f of 5 is 6, but f of -2 is also 6. Okay? But remember, this is still a function because it passes the vertical line test, but it's not going to pass the horizontal line test. And we'll talk about one-to-one function in chapter 3. But for right now, we're just focusing on how to read increasing, decreasing constant intervals and how to evaluate functions graphically. All right, let's go over example 2. And then I will stop this video. Find the local minima and local maxima and minima of a function given the graph. So anytime you have like a U shape and you have a lowest point, this is going to be your local minimum. Okay? And anytime you have a peak, okay? This is going to be your local maximum. And you see how the keyword is, the word is local. It's not the absolute minimum or absolute maximum. We're not looking for the tallest person in the whole world. We're just finding the tallest person in this area or shortest person in this area or the highest point or the lowest point. So if you're looking at this W shape, I can see that this point right there is local maximum. Okay? And this point and that point, these two are local minimum. As you can see, this graph continues increasing to the right and increasing to the left. So we are going to have higher points than this point, but the way anytime you have this kind of upside down U shape or a peak of a mountain, we're going to call them local maximum. Okay, it doesn't have to be the highest part of the graph out of everywhere. It just has to be highest in this local region. Okay, and the local minima we have there too. So let's go ahead and write the usually order pair is okay, but I noticed how your homework was asking, so I kind of borrow their wording over here. All local minimum values, when they're asking for, let me just box up values, they're asking you to give the y value, okay, the value, the minimum value of f, okay? So we're looking at the local minimum y values. So how low do they go? How low? They go as low as -5. You see? They go as low as -5. And all values at which f has a local minimum. And this is asking for the all values at which. Okay, they're asking for the x value of local minimum. Okay, and it happens at x equals -4. As you can see, this has an order pair, x coordinate of -4. And the second local minimum happens at +2. So the answers are x equals -4 and x equals +2. All right, let's read the maximum. There was only one maximum, and the local maximum value, how high did it go? The y value is 1, right? The y value is 1. And they're asking if the wording is at all values at which f has a local maximum. They're asking for what is the x value. This is asking for x value of local max. My dogs are fighting over a food bowl. Oh, goodness. All right. Anyways, x equals, the x value is -1. So I think finding local max and min given the graph is not too difficult, but it's just the wording. If they're asking for values, you're going to give them the y value. If they're asking for like a location, like at which, or like what, they may even just ask you to find the x coordinate. But I think your homework had these wordings, so I wanted to go over them in this notes. All right, let's do one more over here. Find the local minimum values of f. All right, let me go ahead and use a highlighter to circle all the local minimums. You know, every semester I put something like this on the first exam, and the students only kind of circle that one. And they say that is the local minimum and that is the only one. But that's not the only one, right? There's another one right here. It doesn't matter how this one is lower than the one on the right. They're both the bottom of these, I guess, valley. I guess I can call it like that. So as long as they are that shape, then we can still call them local minimum. So how low does this first one go? As low as -3. And this one, how low does this point go? And I mean, we have to be careful because this guy is sitting right at 3, but that is the x-coordinate of this point. The y-coordinate of that point is 0. Therefore, we're going to give them 0. Okay? The y-coordinate, let me go ahead and write down the order pair. This local minimum was -2, -3. And if they're asking for the minimum value, we're giving them the y values. That's why I have -3, okay, and 0, okay? But they're going to ask you to give them the x-coordinate right here, all values at which f has a local minimum. Now we're going to give them the x values, okay? X values are x equals -2, okay, and 3. Where did I get them? Well, you can see how we have the x-coordinates of these local minimums are -2 and 3. Okay? All right. Now let's do local maximum. Okay. I can see someone just circling that one and say, that's my local maximum. But as you can see, there's another one up here. Okay? Anytime you have these peak of these mountains, they're called local maximum. So if you want to write the order pair first, this point is 0, 3, and this point is -4, -1. So when they're asking for the maximum values, I'm going to give them the y values of these 2 points. Y values are -1 and 3. And all values at which f has a local maximum. They're asking for the x values, and x values are -4 and 0, okay? -4 and 0. Okay, I think that's enough for the first video. I will be back to record the second page very soon.